record this. So these are the three views that we're going to bring in, plus the isometric. I'm going to change the ISO view to 2/3, which is what the instructions say to do. And I'm also going to change, excuse me, its display style to shaded with edges. So now here's the reason why we want to bring the views in this way. Let me first select the front view and go to display style. And now I'm going to say I want to show my hidden lines. And I don't see too many hidden lines in here. So that's one good reason why it's it works as a front view. But I don't see too many center lines either. So I'm going to go up to annotations tab of the command manager. Use the centerline command over here. I'm going to select the select a view checkbox, and I'm going to select this view, and this view, and put some center lines in. But you see what it does is see where it puts these center lines here. That tells me that this whole center line is right in line with this edge. So that's where the center line wound up. So that's kind of confusing right there. So I'm going to delete those guys. And then it also looks like it puts center lines in this view that correspond with these radiuses. And once again, they're kind of in the way. But you can see at least that the center line does not override the visible line, even though that visible line is a tangent line. So one of the other options I guess I could do is if I undo this, so that center line is back there, I could go to this view and highlight it and say I want to remove the tangent edges. And now you can see that center line there. So you could took away those tangent edges. And I can do the same thing with this view. Go to tangent edge, removed. But just the same, we don't normally.
That's just right click and you get up.
Yeah, just right click right here. Sorry, right click brings up this menu, and then go to tangent edge, and then tangent edge is removed. So we don't normally show these things anyway, so I'm going to get rid of them. All I really needed was a center line for this guy. And then, of course, I don't have any center marks in here, so it'd be nice to add a center mark into these circles right here, too. So I use the center mark command, and I have plenty of options here in the property manager. It's asking me if I want to do a slot center. I don't have any slots to worry about. If I want to, right here, I'm doing a single center mark whenever I select the circle. But if I use this linear center mark option here, and then say, hey, I wanted some connection lines and a short center mark in the center. Now when I select this guy and then select this guy, it adds a center line between them. So it connects everything, which is sort of okay, but then it overrode this one a little bit. So there's always some kind of thing going on that's like, why the heck, so if that center mark wasn't there, well, then what I'd have to do is start all over again. But if I redo the center marks now, with these things selected, the linear center mark, now if I select this and then select this circle and then this circle, now it puts some nice center marks between all three of them. And each one of them has a mark in the center. Just a little side, an aside to show you what SolidWorks can do. Okay, so why did we choose these three views? We're going to replace this view with a section view. So that means I'm going to be sectioning this view right here. And I'm going to use what's called a full section. So I want to put a section view in here to replace the top view. I'm going to move this guy out of here a little ways. Give me some room. If I go to the View Layout tab on the Command Manager, go to the Section View command here. Again, I get a Property Manager that gives me a few options for a horizontal or vertical center line, an aligned or an auxiliary center or section line, not center line, excuse me, section line. And this is checked. I think this was unchecked originally. Auto start to section view. And I might have checked it this morning. You can go either way, and I don't think it really matters that much. But I know I'm going to have to section this, the part this way, and I'm going to have to section it long ways in order to get a view that looks like that one. So horizontal is what I want. And notice as soon as I get into the view, it shows me some section, a phantom of a section line, a cutting plane line. So I want to cut this thing right down the middle. So I'm going to pick this circle until the center it highlights, and then go down to the center of it and say, that's where I want to put my my cutting plane line. And then, of course, gives me some more options. Do I want to do some sort of radial or arc offset, a single, or some sort of a notch, or undo the whole thing? Nah, I'm just going to say green check. I'm good. And I started with AA for my section view, but I want to put my view up here, and you see it's not facing the same way as the top view. Okay, that's because when you cut a section into a part, you have to use the same rules for third angle projection as you do for the orthographic views. So that means that the way the section lines are pointing, the arrows are always pointing to the material that you're keeping. So we're cutting away this bottom part of the part. So that means in order for us to be correct in our view presentation, we need to actually roll our section view down underneath, which is what we're doing right here. Properly done, this section view should be down here. But I want to change it so that it can be up on top, which means I need to flip the direction of the arrows. I can double click the arrows here, or I can just go over to the Property Manager here and say, hey, I want to flip the arrows. And they flip for me. And now the view looks like it's supposed to. And so then I can place my section view. And if I'm done, which I am, say OK, and then highlight the top view border, hit the delete key on the keyboard, or right click it, and I can find delete in the menu, and just say, yeah, I want to delete that guy. And so now I've got a section view that replaced my top view. It's aligned with that front view like it should be. And I'm good to go. Well, that's part of the second half of the project already. So I'll kind of give you a little bit of a jump on things there. The first part of the project is doing some stuff we've already done, modifying the title block, and adding dimensions. So we're going to add a couple of dimensions. Let's add some linear dimensions, the width and the length. So I auto-spaced them, but you can see that they're in conflict with the cutting plane line. And then I'm going to add a dimension to the hole, but every time I pick the hole, I don't get the whole circle, do I? I just get sections of it. That's because it looks like an entire, a full circle to us, but in reality, since we're taking this view from the part, it's this arc plus these arcs plus this arc right here. So no matter what I do, I can't pick the whole thing, I don't think. And if I just pick one of these and put my dimension out here, it dimensions it as a radius because that's what it sees. It just sees that portion and says, hey, that's a radius, it's an arc. So I need to change that to specify it as being a diameter. The way I can do that is highlight this, the dimension, go to the property manager, and if I look down here, I won't find any way to change it. If I go to this next tab where it says liters, now if I look at, now I've got options to modify my liter. Pretty sure there's nothing in here that would say to show it as a diameter dimension. But if I go back to the liters and I look at these tiles, and I look at these tiles down here, this tile is the one that's selected, and that says radius on it. This one next to it says diameter. So if I just change it from this one to this one, the dimension updates to a diameter dimension. So you're gonna have to look out for things like that when you're dimensioning drawings in SolidWorks. Now I'm gonna move this guy out here and do a couple things. I believe it said for the height and the width that we want those to be basic dimensions. So in order to change them, all I need to do is highlight the dimension and then look at the tolerance and the precision of the tolerance that I'm using here in the property manager. Right now, I don't have any tolerance selected for this dimension. So if I hit the pull down, oh, wrong pull down, this one right here, the very first one is basic, right? And that's what I'm pretty sure the instructions say, that these dimensions should be basic dimensions. So if I just select basic, it puts a box around it. And then it moves it back, which I don't want it to do. And that's a basic dimension. This one also needs to be a basic dimension, so I'm going to do the same thing for that. The size of the two holes should have bilateral tolerance of +2, -3. So this is the dimension for the two holes, but I'm missing something, right? Should say 2x. (2x) diameter 1.34. And it needs to be, what did I say, +2, -3, bilateral, right? Bilateral. So again, I highlight the dimension. I look at the at my options for tolerance, and bilateral is the third one, or the second one, really, down, just down from basic. So I make it bilateral, but I got nothing in here yet because I don't have anything in these two boxes. So bilateral is a ± tolerance where the upper limit and the lower limit are different. So this one is supposed to be +0.002, and the lower limit is 0.003. And I say okay, right? Or hit enter, hit the green check, and what do I got? I got nothing there. Why? Anybody?
I don't know.
Precision's not right. So I need to change the precision.
Oh, yeah.
It's only two places.
Right.
And the rule of thumb is that whatever the decimal places are for the tolerance, the primary dimension should be the same.
Right.
So I need to go in here and I need to change my precision for the nominal to be 3 places. And then if I look at the precision, this is the precision for the nominal. If you can see it, it shows the nominal dimension highlighted in blue. And then the upper and lower limits blacked out. And then here is the precision for the tolerance. And then the tolerances are blue and the nominal is blacked out. So here it says same as nominal, which is standard for ANSI dimensioning. So anyway, I changed my tolerance, and now my dimensions read like they should. It's a diameter 3.43 plus 2 minus 3. I believe it said the base should have, let's say, tolerance of plus or minus 5. Was it symmetric? No, limits. Thickness of the base should have limit tolerance of plus or minus 5. So let's do that, guys. We can do the thickness of the base in this view, or we could do it in the section view. Either one, I don't think matters. So I'm going to go ahead and say 0.75. My tolerance is going to be symmetric. No, limits. I'm sorry. Limits, and it was plus or minus 5, right? Is that right?
Yeah.
I think so. So plus or minus 5, but again, I'm not seeing much here because I'm only 2 places. So I want to go and change my precision to 3 places. So now I'm showing 755 to 745, plus or minus 5, because the nominal was 750. And then we'll pick another. No, let's not pick. Let's see. The overall width and length should have a symmetric tolerance of plus or minus 10. Oh, the location. Oops, I did the wrong ones. Location of both holes should be basic dimensions. My bad. So it says the location of both holes should be, and these guys should be plus or minus 10. So we can change these guys. I can highlight this dimension, hold down Control, and highlight this one. And now I can change the the tolerance from basic to symmetric, and it was 0.010. Where was it not? 0.010. And then again, I've got to go 3 places to show it all. And now I've got to add some dimensions for the for the location of these holes. And those should be basic dimensions. And then should I add a dimension to the center? Yeah, I could.
Mhm.
But we kind of already know that the holes are on center. So, and plus you got this cutting plane line in there, and that's going to be an issue as well. So when you call these out, you could say on center, or in the old days we would put a center line symbol right in here on this to show that this is the center line, and then we could say up here that it was on center. So I don't know if that's going to fly these days or not. You might have to, in order to make it clear, you might have to go ahead and put a dimension out here and call that basic also, just to be safe. See, this is one issue with using the automatic spacing is that once you space them that way and you modify them, sometimes they want to drop back off and move back to where they were. So that's the first half and a little bit more of the P39. I didn't do everything for the first half. You've still got to, modify, add a few things to the title block, add a revision block, and some other things. And so I'll let you guys do that. Any questions on that? If this is successfully recorded and uploaded, you'll be able to see this again whenever you want.
I do have one question, if that's
Sure.
all right.
Yeah.
When we marked the center lines for the original views, I see that they're not on the section view. Do we want to have the center lines on that or no?
Again, the only one that you might want to put a center line on would be the counter bore. So,
Gotcha.
yeah. So if you want to just do the counter bore, the best thing to do is to use the centerline command without the select view. When you use the centerline command without the select view option checked, you have to pick the two lines that you want the center line to go between. So I would want to pick these two lines or these two lines, which kind of works, that way. I mean, that's not a bad looking center line. What you have to be, but it's actually two center lines. You see that? If I delete that one, there's just this one left. What you have to be careful about is making sure that you don't accidentally pick, and I'm over exaggerating here, two lines that that aren't the right two lines to be the center lines, because it'll still put the center line directly in the middle of the distance between those two lines, but it's definitely not a center line of the part. So, and like I said, that was an exaggeration. But there's times when you have a line that's close that you might accidentally pick, and it won't be the right center line. And if you start dimensioning from that center line, well, then you're going to have some problems. So just make sure you know what you're picking when you pick it. Nice if I use the right command. And in a case like this, I wouldn't add that second center line. I'd just go ahead and highlight the line so that the endpoints show up, and then left click and hold this guy a little so I can drag him down a little ways, and then make a nice center line out of him that way. So yeah, you'd probably want to show the center lines in there. You don't definitely, if there's any hidden lines, you don't want to show those.
Gotcha. Okay, thank you.
Okay. Actually, I'm not even sure. Let's find out. If I select, yeah. See, if I select this section view, it doesn't give me the option. It does give me the option to change how it looks. Look at that. I can actually make it look like a sectioned solid part.
Mm-hmm.
But that means I could also add hidden lines. And hidden lines are a no-no in section lines. So I'm not even sure why they give you that option, but they do for display style. But you usually don't want to show the hidden lines. Interesting. You definitely don't want to show it. There's only there's one exception to the rule for showing hidden lines in a section view. And we won't come across that until we're almost done with the semester. Okay. Anything else? All right. So we got a little bit of a introduction into section views. We're going to do some more. With this part right here. This is This is one that I made that looks like the 5.4.1 exercise that that the PowerPoint asks you to do. It's on page 5-23. So I'm going to go back to the PowerPoint and let's go take a look at a few slides in this thing. Yeah, we won't look at that. What's a section view look like, and what are we talking about? It's like we're sawing the part in half. So if I were to take this part and saw it with a bandsaw, this is what it would look like, and this would be the area where the saw cut through the part. Anywhere that the saw cuts through the part, as it were, the virtual saw, is the area that's bounded by a visible line, and we'll have section lines in it. So, and we're doing it in order to expose features that are inside that we can't normally see, or that would have to show with hidden lines. For example, this land right here, which I could guess, would only guess that if it were a real part, would be for some kind of a snap ring, or although I don't know how you'd get it in there, or an O-ring. I could see maybe you could get an O-ring stuffed into this, but you wouldn't be able to see that without sectioning the part. So this is how the cut material is shown with section lines. Obviously, when you're doing it with SolidWorks, it's no big deal because it kind of does all this stuff for you. Once you figure out how you're, the only hard part is putting the cutting plane line on the part where you want it. But it cuts the part for you, puts the section lines in, gives you the titling, does the cutting plane line and arrows for you. It does all of that. So the cutting plane line shows where the object is being cut. I guess that seems pretty obvious. Arrows point to the portion being kept, like I said before. So if we're removing this portion and we're looking at it from this direction, we need to show it to the right side, the back side of the arrows. It's always to the back side of the arrows. That's the easiest way to remember where the section view goes. Always goes to the back side, and if that's not where you want it, then you got to change the direction of the arrows. Section lines indicate where the plane would cut the material. They're thin lines, and they're actually symbols chosen according to the material of the object. And they're usually drawn at 45-degree angles. If there's no material called out, then the general section lines that are also used for cast iron are used to make the section lines in the part. So here we go. Want to make sure I'm not skipping any. We're going to learn how to change the material type in SolidWorks in a drawing. Cast iron is the repeating lines at a 45-degree angle that are equally spaced. It's cast iron or general use. Steel is a pair of parallel lines, and then a large space and another pair of parallels, so on and so forth. You can see it all from here. Stuff like concrete is the only one that doesn't really have any lines in it. It's designed to show the aggregate. If you were to cut something made out of concrete in half, you'd see the stone and the small air bubbles and things in it, and that's what this is designed to represent. There's a different pattern for almost every type of material. Some of them repeat, like this, rubber, plastic, and electrical insulation. It's kind of all shown the same way. Rules for drawing section views. This is by hand. The section view is completely bounded by the visible outline. the section lines should all be parallel. These lines should all be parallel and should all be at a 45-degree angle. Visible edges behind the cutting plane are shown. That's what these are, the visible edges behind the cutting plane. And all hidden features are omitted except for threads and in broken out sections. And so here we're looking at, you know, 3 of the majors that you probably use most of the time. A full section like we did on that part in SolidWorks, all the way across from one side to the other. A half section, which we're going to do with this sample part in the book. We're just cutting it. They call it a half section, but you're really only cutting away a quarter of it, aren't you? So it's half because you're only cutting halfway through the part. You're not cutting all the way through the part. But in reality, you only remove a quarter of, you know, if the part's symmetric at least, you're only removing a quarter of the material. So that's a half section. An offset is designed to basically take features that are on different planes and kind of move them, as it were, in the section view, offset one of them so that they wind up being shown together in the section view, like so. Rather than having to do 2 different sections, we can just offset the cutting plane line like you could with a you know, a bandsaw with a really small blade, more like a scroll saw to make a corner like that. But you know, whatever, you can round the corner and you could cut it through like that. And that's what you'd wind up with. When you looked at it directly on, this is how you would see it. You wouldn't see the fact that this is farther back than this, even though that's the way it is. But in a 2D environment, they're on the same plane. We okay so far?
Yes, sir.
All righty.
Yep.
So how and why do we create a full section? The full section cutting plane, again, goes all the way through the part, and it's used to having to do this, so you don't have to do that. It's used so that you don't have to dimension to a hidden line. So you can dimension to a solid line in the section view that would be hidden normally, and also exposes maybe some features that you can't normally see. Here's a case where we're doing a half section on a part that's not a round part, yet we're still only cutting halfway through the part. And this is how it's displayed. Only 1/2 is sectioned. It's used mainly for symmetric objects. And a center line separates the 2 halves. So this half has not been cut through. So all we're seeing is the outsides of the part. The center line separates the cutting plane, and from that point to the right, we're seeing everything that was cut away. But we still see the whole outline of the part with visible line. Everything that's cut away doesn't extend out into here because it would have to be hidden line, and we don't show hidden lines in section views. Offset sections, you're bending the cutting plane to show features that don't lie in the same plane. Again, Les, I think I explained that one well enough already. We're just basically aligning them again so that we can see them all together on the flat surface. Now, this is an exercise in the book that I'll let you do on your own, but if you open up the PowerPoint while you're doing it, you'll see that it gives you basically everything you need to get it done. We're trying to display this hole here, the one back here. We're cutting this part basically just right down the center like that. So when we do that, this is what we're going to see. We're going to see half of that big hole here. We're going to see these 2 edges here, which represent this corner and this corner. we're going to see this solid circle, which represents this diameter cut through the part. That edge right there is this edge right here. And then again, since we came over and up and over this way, we're going to see this edge right here too, shown like so. Again, look at the projection lines, see how they help to create that section view. One more reason why projection lines are important. And drawing these parts aligned the way they should with the 45 going up this way, so that the spacing from here to here is the same as the spacing from here to here, so that when you transfer over, everything transfers like it's supposed to. We're getting farther and farther away from having to do all this, but it doesn't hurt to reiterate it. And then the last thing you would do would be to add the section lines for the type of material that it is. And I don't know if they said it was steel in the beginning, but these look like steel lines to me. Section lines are bound by the visible lines, and so that means that they don't spill over onto the outside the visible line, and they also don't spill into areas where the material wasn't cut. So this half of that hole wasn't cut by the plane or the imaginary saw blade, so you don't put section lines in there. This area here also was not touched by the cutting plane or the whatever, so it gets no section lines. Only the areas where the material was actually removed gets the section lines. And that's something to remember, because if you guys turn in any of this stuff hand drawn, I'd be willing to bet I'll find some drawings where there shouldn't be section lines and there are. And this is the exercise that that I have on SolidWorks, that I kind of recreated this part. Didn't have any dimensions for it, so I kind of had to guess, but it's fairly close. Good enough so that it looks like the part, and I can section it. And so what it asks you to do is create a full section of the part here and put that section view up here, and it already has it outlined for you. And then over here it says do the half section, and again you're going to display it out this way, and that they've already drawn the outline for you on the paper itself, on the sheet in the book. All you've got to do is kind of basically follow it, then decide what gets shown and what doesn't get shown. That's the secret. But again, if you follow the PowerPoint, the answers are there for you. So this is what the full section should look like. It should look just like this one. Same outline. The only difference is that everything that was hidden is now solid. With the half section, we're only showing this material because we removed this quadrant here. So everything that's above this line gets shown in solid line. So half the diameter, half of this taper, and this shoulder right here, and then all of the outline of the part gets shown in solid line. But this solid line extends all the way up to the center line, because that's part of the outer portion of the part. That's this edge right here. And that extends all the way up to here and then stops. But on this side, it only extends down to here because it's cut away. So once you get down to this, the outer diameter of the smaller portion of it, that line stops, just like it does here. For this section view here, we remove the line from here to here, right? Because we're cutting the part in half, so you wouldn't see that line, because this would be all homogeneous material. Questions? Clear enough? Do I need to explain it? try to explain it a different way.
It always looks easy right now until you try to do it.
That is true. That is true. So, but you have this for a guide.
Absolutely.
And hopefully that'll help. And I do, there are problems in the assignments where you're going to have to draw this stuff by hand and submit it. Does anybody have any issues with being able to submit to Eagle? I gave you 3 file options: JPEG, PNG, and PDF. So at the very worst case, you should be able to take a picture of the page in the book with your phone, hook up your phone to the PC, or email it to yourself, and then take the attachment from the email and submit that to the assignment. Or hook up your phone, transfer the file, and do it that way. But it's fairly straightforward as far as submitting. And I think you guys probably have all done it already anyway. But if you have any issues, give me a holler. What's next? And then the section lines, I think they add at the end. And P39 we already talked about. Only work to Rev A. Rev B will be discussed in Chapter 5. So that should, I think, just about do it. For that. Again, let me show you really quickly how to do this in SolidWorks. And hopefully the results will look the same. I want to do a full section of this guy. So again, I'm going to go to View Layout, Section View, my horizontal, pick that midpoint right there. Select OK. And I'm at FF because I played around with this before, so I'm going to just force it to AA. And then my arrows are the wrong direction, so I'm going to flip the direction so I can put it up here. And there's my section AA minus my my center line. Now for my half section, I use the same command, section view, but this time I go up here, and where section is highlighted, I change it to half section. And when I do a half section now, it gives me 8 different possibilities to create that half section, 8 different directions, basically. Fortunately, it's already defaulted to the cut that I want to make. And when I drag my cursor in, you'll see that the cutting plane line starts no matter what view that I put it in, but I don't really want to do a half section in this view. I kind of want to do it in this view. And it knows how big the part is, so it's already got this guy outside the part. And it's very easy. All I need to do again is find the center of one of these circles, pick that as my point to place it. And now this time my arrows are pointing the right direction because I want to go out here, but my lettering reverted back to the sequence that it was in before. It was FF, and I changed it to AA. Now it's jumped up to GG. So once you start messing with it, you got to keep messing with it. And I want to make it B just to stay consistent. And notice it already put the center line in for me, but I wanted to do this for you just to show you that, in fact, when SolidWorks cuts the half section of this part, it looks exactly the same as it did in the book and in the PowerPoint. So that means somebody's on the right track, or they're both wrong. and nobody's discovered it yet. But I think they're probably right. Any questions? We'll have a chance to practice this some more. And on Wednesday, we'll be doing some offset sectioning on a part that's a little more complex. It is in the book, but I don't think it's in the chapter. Yeah, actually it is. It's exercise 5.4.2. We're going to start doing some, we're going to do some offset sectioning on that part on Wednesday. So probably what I'll do is, if I have time, I'll do a video in advance. And hopefully you'll get to take a look at that. Otherwise, I'll be here at 4 o'clock on Wednesday for whoever wants to show up. I'm going to stop my recording now.